So, what I will be talking today is about deployments. How do we deploy applications, right? There are quite a few ways. I'm not going to go through all the ways how you can deploy. Most of them are stupid, so I'm going to skip them and just go through those that are commonly used today, at least some of them. So let's, okay, so this is how I look like. My name is Viktor, you already heard that. I work for CloudBees. I'm one of the Google developer experts and I'm one of the Docker captains. I have blog, I have books, I have more books, I have podcast, I have Twitter. That's all you need to know about me. So we can now go to the cool stuff. So what I did before I came here, I created the Kubernetes cluster. I will not bother you. Who's using Kubernetes here? The rest of you, be ashamed forever and ever. Anyway, I'm going to skip the part explaining how I created the cluster. This is boring, and we're going to jump directly into deployment. So, deployment is one of those things that in many companies, unfortunately, developers do not really care. It's kind of like it's somebody else's job, and then they create some silly applications that are not deployable. They don't know how to design them to be scalable, and all those things simply because they don't really care, which is completely, terribly, awfully wrong. So what I'm going to show you is four commonly used strategies. I'm going to comment on how they work and why they do what they do and so on and so forth. I don't like to speak for a long time, so I'm going to jump into demos right away. But before that, let's talk about expectations. What do we expect from deployments or from our applications? Now, there are many things that you might expect, but the ones that I care about in this context is, first of all applications need to be fault tolerant, right? And I assume that all those things are more or less a given, right? You already do those things. If you don't, just let me know. You will not let me know because you would be ashamed, I understand that. But they need to be fault tolerant, right? Your application goes down, it is recreated, restarted, rerun somewhere automatically. Like node goes down, that application is moved somewhere else, and so on and so forth. The whole cluster goes down, you're running 3 clusters in 3 different zones, right? All those stuff, short version, needs to be fault tolerant. And the main reason why it needs to be fault tolerant is because I really don't like to receive a call at 3 o'clock in the morning saying this does not work, right? So fault tolerance, that's the first requirement. Second is highly available. Nobody wants to go to a website and see that it doesn't work. It needs to be highly available. Normally we talk about how many 9s after 99 of availability we are having. Definitely not less than 2. It needs to be responsive. So it's not only about application being up and running, but also being able to respond to the requests. And that usually means that it needs to be scalable, right? It cannot be responsive if a single instance can handle 1,000 requests and then you have 2,000 requests, concurrent requests, and then it just breaks down or it becomes slow and stuff like that. Usually responsiveness goes with scalability. It needs to roll out progressively, right? What that really means is that I don't want to do big bang kind of like, let's see what happens when I make a new release. I want to gradually ease my users into it, probably watch some metrics, probably do some testing and stuff like that, and then progressively move forward and forward and forward until my new release is completely rolled out, right? Otherwise, it's like Big Bang type of approach, and I really don't know what will happen until it happens. Because realistically, the only way to really truly test your application is in production, just to make it clear. I'm not saying you shouldn't be testing before production, you should, but until your users start using a new release, you have no idea what's really going to happen, and that's unavoidable. If something goes wrong, we need to be able to roll back, right? That's another requirement, one way or another. It needs to be cost effective. And this is where most of the companies I work with are failing, kind of like the easiest way to treat your application is to say, okay, so my application most likely needs 4 gigs of RAM, so I'm going to request servers with 16 gigs of RAM. I'm going to take 5 of them just in case to be safe, right? That's a bad idea. Money is important here as well. So, I'm going to walk you through 4 different strategies. I'm going to switch to my terminal screen from now on, and we're going to see how that looks. First, we're going to start with the new buzzword, not new buzzword, it's like 5 years old or something like that, but serverless, right? Let's see how serverless deployments work. I will be doing everything in Kubernetes today, simply because Some of you use Kubernetes, and those of you who don't use are ashamed. Anyway, you will be using Kubernetes. Everybody will be using Kubernetes today. So what I did before I came here, I created this strange YAML file that contains some stuff. I'm not going to bother you now with it. The only thing that really matters in this YAML file is that it specifies a container image, Docker image, call it. It's not really Docker anymore, container image. That defines, okay, this is my container, this is my image, do something with it. What that something is yet to be seen. So I'm going to show you now. So let's take a look what is running in my cluster right now. So what I have right now, with the name Knative, because I called this first application Knative. By the way, I'm calling it Knative because I'm using Knative framework, which allows you to run serverless deployments in Kubernetes. But it's just an example. You can do it with whatever you want. And anyways, right now, nothing is running in my cluster, right? At least nothing tangible, nothing physical, and all those things. And the reason why nothing is running in my cluster is because my cluster killed all the applications that were running there. And it killed all the applications that were running there simply because I was not using that application for a while. Neither me nor anybody else used it. So the system decided, if nobody's going to use it, then the best thing to do is to kill it and to free resources for something else, right? And now if my cluster is set to auto-scaling, then probably my cluster contracted as well, reduced the number of nodes, did whatever it needed to do. But the point here is that things are running only when needed, and now nothing was needed for a while now, so nothing is really running. And that is saving me a lot of money, and saving money is good, it's important, because I don't really want to complain to people how I don't have enough of it. Anyway, so what I'm going to do now is that I'm going to run an application, tiny application called Siege. Anybody familiar with Siege? No? Siege allows you to send HTTP requests to your application. I'm going to start sending requests for 20 seconds. I will be sending requests to my application. I will be sending 300 concurrent requests in parallel, right? So 20 seconds, it will be bombing application with 300 concurrent requests all the time, right? And the reason why I'm going to do that, and at the end of this process, after 20 seconds, I'm going to output pods. Pods, if you're not familiar with Kubernetes, is one or more containers running in a cluster. If you're not familiar with containers, then you're in the wrong place. Hopefully. Anyways, so once this command is finished, I'm going to output all the pods, and we're going to see what happened after I started sending 300 requests for a period of 20 seconds. There you go. I sent 2,221 requests during that period of time. I had availability of 100%. 100% of those requests were handled by applications that did not exist in my cluster. And the reason why it didn't exist, because it's serverless, because it's not running when it's not used. And the system, in this case Knative, what it did is that it created those 3 replicas of my application. Over there, those 3 here were created. And the reason why we got 3 instead of 5 or 7 or 2 is because I configured my application to handle up to 100 concurrent requests. So 300 requests in parallel, that's 3 replicas of my application. And soon, I will not bother you to wait, you need to trust my word. Soon, 2 of those will be removed, and then a bit later, the 3rd one will be removed as well if I continue not sending any requests to that application, right? So what happened is that my system, I sent a request to my load balancer. Load balancer sent it to an API gateway. Think of it in abstract term. The real job of this gateway, it's very lightweight. I think it's 10 megabytes of memory that uses something like that. Anyway, what API gateway does is that it accepted those requests, evaluated, spoke with Knative and asked him, okay, so can you handle this? No? Okay, then do something. Start instantiating your application so that these requests can be done. In the meantime, Gateway was queuing those requests, waiting until the application was up and running. And then once it was up and running, a second later, something like that, it let those requests continue flowing until the application. Okay, so if I go, now I told you some requirements at the very beginning. there were 6, now there are 5. The one that about fault tolerance, I'm going to ignore it from now on simply because no matter what we do, no matter how we deploy our application, there will always be fault tolerant in Kubernetes because that's what Kubernetes does. But the rest of the things really differ from case to case. Was my application highly available? Yes, at all the time. You saw 100% of requests. They were all received and responded. Was it responsive? Not really, partly, somehow. And the reason why I'm saying it's not responsive is because some of those requests took maybe a second to respond instead of a millisecond or a few milliseconds, simply because it required some time for the new instances of my application to start running, right? So it's not fully responsive. That's a downside of this, of doing this. Progressive rollout, I'm going to show you how progressive rollout works for real a bit later. For now, just think of it as, it was not really, if I deployed a new release, then somehow it would manage the differences between the old and the new release, but not in the best way. There is no way to roll back. And just by the way, when I'm telling you there is a way or there isn't a way, I always mean automated. I know that I can do everything myself. I can SSH into machines and roll back, right? But in my head, when I say something can be done or cannot be done, I mean automated without humans. So without any of you being involved. You're drinking coffee, machine does something, right? So it does not really roll back, but it is very cost effective. I'm just using what I have. I'm using what I need and I'm paying for what I need, more or less. It's not maybe as cost effective as Lambda and similar functions as a service type of stuff, but they are evil, so you shouldn't be using them anyway. Okay, so let's take a look at recreate strategy. And by the way, if you have any questions, that's even better, so ask me at any moment. So the second one, recreate. This is the strategy that most of you are using right now. You will not admit it in public when you see how it behaves, but this is what most of you are doing. And actually, recreate is not a good name. I think it should be called Big Bang. Meaning that I'm going to destroy my release and then I'm going to put a new release in its place. Right? That's how you can translate recreate strategy. So let's take a look what happens with recreate strategy. By the way, while I was talking, you can see that only one of the 3 is left. And soon that one will be gone as well. Anyways, where was I? Let me see, recreate strategy. Here are my notes. I can copy and paste so it looks like I know what I'm doing, when in reality I might not. Okay, so what I'm going to do is that I already have my application up and running, the second one. I'm going to show you that. Grep. You can see that I have 5 replicas of my application running. The second one, recreate, it's happily serving my requests. It's all great, it's all peachy, everybody loves it. So what I'm going to do is that I'm going to simulate a new release. I'm going to change my code, right? I'm just going to change output message of my application from something something example to something something recreate. So there's a single word of a difference, and I'm going to push that to my Git repository. Yeah, by the way, what I didn't say is that in this context, even though it's not really part of the topic, I'm using Jenkins X, so whenever I push something to the repository, it will automatically deploy my application. So we'll need to wait until a minute maybe, until this new release is up and running, and then I can show you how it works. And during that time, I'm going to show you, I know that you get bored with looking at the terminal all the time, so I prepared something with colors, like graphs. So this is how most of you are deploying their application today. You have a load balancer. If you're using Kubernetes, it goes to Ingress. If you're not using Kubernetes, it doesn't go there, doesn't matter. It goes to a certain release, let's say version 1 of your application. And then when you need to deploy a new version, you're gonna shut it down, right? And then you're gonna put the new version in its place. This is what most people are doing today. Unfortunately. And I'm not gonna ask you if you're one of them because you won't admit, I already said it.
But if I'm doing that with Kubernetes, the default is rolling updates. So
the default is rolling updates, true. But rolling updates does not work for most people.
Well, it all depends. If I cannot run with old and new versions at the same time.
Exactly, exactly. If your releases are not backwards compatible, or if they are stateful, right? You're going to lose the state, or you're going to, if it's not backwards compatible. So the only way how you can avoid this is to run 2 releases in parallel, which is where you're probably going. And those 2 releases need to be backwards compatible with the database, with this, with that, IPI version and stuff like that, right? So yes, rolling update is default. Everybody uses it, and then they discover that their application doesn't support it.
Well, hopefully they figured that out before they did it.
No. That's
Just
what I
like
would hope as
DevOps
well.
and unicorns, it's just as
That's what you would think, but that's not true. Because unfortunately things were done more than a few years ago. And a few years ago things were different. So what I'm going to do is in this terminal I'm going to start sending requests to my application. See what matters right now. Do you see this? No? This country, you don't complain. There you go. Do you see it now? Excellent. So you can see that I'm receiving HTTP example. Pay attention to the word example. Basically, I'm receiving requests from my application. It's still running the old release. And let me see what's happening. JS-get activity, JS.recreate. I'm still waiting. My application is almost deployed. Soon it will be running. Let me see. Almost there, almost there. Or maybe I messed it up. There you go. Come on. I messed it up probably. Or not. Let's see, let's see, let's see, let's see. This is like excitement building. Will it work? Will it not? Probably it will not. Ah, there you go. There you go. On the left side, right? The reason why I'm seeing this is because I had to shut down my application for whatever reason that I mentioned before or many others, like it's not backwards compatible, maybe APIs are not versioned, maybe I cannot, I need to shut it down to update my database, or whatever the reasons are, but in most cases those are the reasons, and then a few seconds later, the new release is responding, everything great. Now, you might say this is not a big deal, right? I had my application unavailable for a few seconds. But it is a big deal if you're deploying multiple times a week, a day, an hour, or whatever the frequency is. Now, if you're deploying new releases every half a year, twice a year, 3 times a year, then really none of those things that I'm saying matters because you have bigger problems than that. Okay, so that was the second. So none of the things that I need work with this. It's not highly available. If it's going to fail every time I make a new release, it's definitely not highly available. Without being highly available, it is impossible to be responsive no matter what happens. Can we have progressive rollout? Definitely not. Can we roll back, at least using Kubernetes out-of-the-box things? No. And even with Kubernetes out-of-the-box, with a bit of tweaking, you can do it, but that's not really real rollback. I'm going to show you later. And it's definitely not cost effective because my application is running all the time, wasting resources and all those things. And without really scalability, without my application scaling, that's definitely out of the question. Okay, so let's see the third one. From here on, it will get only better. So what we're going to do next, what I'm going to do next is first I'm going to execute the commands. Where are the commands? Okay. I'm going to go to the third application. I'm going to change the text from example to rolling, just so that you can see the difference. I'm going to go back and push it to my GitHub repository, so soon it will be deployed. And what we're going to do next is something like this. We're going to run multiple replicas of my application. 3 replicas in this diagram of version 1. And then instead of shutting it down and putting a new one in its place, we're going to start replacing replicas one at a time, right? If you're running many replicas, maybe it's 5 at a time or 20% at a time, whatever the frequency is. So for this to work, both of those releases need to be backwards compatible. Their APIs need to be versioned. Their database schemas need to be backwards compatible, and what's or not. Everything that you do needs to be backwards compatible, because the only way possible, physically possible in the world, to avoid downtime when you deploy your applications is for 2 releases to run in parallel. No matter which technique you use, it will be impossible to ever deploy without downtime, without having 2 releases in parallel. Defies logic of physics. So it will periodically, it will one by one start replacing my replicas of the old release with the new release, all the way until at the very end, it will be running only the new release. And we can see how that works. What I'm going to do is that I'm going to start sending requests to my application. Where is my application? Here. Still responding the old one. That's cool. Let me see whether JX get activity, whether it was, what's the name? Rolling. Whether I deployed, still not there.
Something is down.
Okay, sorry for that. Still deploying. I mean, building, running tests, and doing whatever I need to do with a new release. But I'm going to be speaking actually about CD pipelines like this one. Day after tomorrow, maybe? I think so. Anyway, 1 more minute. Okay, 1 minute for questions. Go. That's a cultural thing, right? You know,
okay.
Yes,
so,
please.
have you played around with maybe introducing some feature switches so that you don't necessarily have to have fully backwards compatible thing for this rolling update? So you roll out the thing and then you have some switch which turns on when everything is rolled out, and you somehow safely do it.
It will still not have, you will not be able to do it that way either.
Yeah.
So first of all, I did play with feature toggles, feature switches, and all those things. Actually, my company bought a company that does only that, so we're very much into that. But the point is that, so let's say that you now turn the switch. Doesn't matter whether you deploy a new release, turn the switch one way or another, right? What happens with the old requests?
Yeah.
They need to terminate. So it's unavoidable that you will have existing requests running on the old release and the new request running in the new release. Unless you can say, when I turn the switch on, kill all the existing requests, I don't care about you guys, everybody goes to the new release, but that would be downtime. I mean, downtime.
Advanced circuit breaker.
Still, you cannot terminate all the requests at the same millisecond. Right? They need to terminate doing something. Right? So, it's not really...
In terms of switchers that will hold, so responsiveness will be a bit less, but at the same time we can have a millisecond when there is no request.
Yeah, so you can say, okay, I'm not accepting, but then it's not responsive. Right?
Yeah, but they are in the queue.
Yeah, if they're in a queue, yes, but then they're not responsive.
Yeah.
Yes. You can wait until all the existing requests terminate and then say, and queue, and put it on.
And then put all new to the...
But in reality, applications that need that, those are usually not the applications that boot in a second. Usually. Then you will be queuing for unknown amount of time because you don't know how much it takes to finish request, and then you're going to spend some time booting your new application, or maybe you will boot in advance.
Implementation stuff.
Yeah, but it's it's better than nothing. Yes.
Error.
Ignore errors. Anybody else? You were saying something.
I'm just saying, you're assuming that every time I push out a fix or I push out a new application, it's a break fix. I mean, it's not backwards compatible. And normally, if I'm going to be pushing out that many iterations, that they are not breaking the previous release, and I only have those very seldom that I have a release that's a break fix.
Yeah, frequency depends from case to case. Kind of, I cannot know in advance how often somebody will break, somebody will not, right? And so that depends there. Where was I? Oh yeah, while I was talking, you can see actually here, it was going all to the old release and then started mixing. This is when all the new release when new release was replacing the old one replica at a time. And then at one moment later, everything is going to the new release. General improvement as long as, and you can mix, going back to your question, you can mix and match. You can say, I'm going to do rolling updates all the time unless somebody says this is going to break my stuff, and then do Big Bang. Yes, definitely. I mean, even better than Big Bang would be, then I'm going to tell my client to always ask for the version of my API, and then depending on the version they see, they do one thing or another to avoid that problem. Anyway, where was I? Okay, so high level, definitely responsive, but pretty much progressive rollout. Yes, again, more or less. The reason why I'm saying partly progressive rollout, because it was really replacing one replica at a time, but there was no real decision making whether to proceed or not. And that is really what was missing to make it truly progressive. Meaning what I would like to see is saying, okay, put one replica with a new release, monitor some metrics or how users behave, what's or not, and then continue progressively by monitoring or running tests or whatever you do to validate that something is correct. No rollback, at least not with the current version that I'm running, and cost effective, that's okay. So
why you said that you cannot roll back with that process? You can roll back to the previous version if you make everything like...
yeah, well, out of the box, when you say rollback without humans.
Well, if you detect some reason for rollback, you could roll back.
Yeah, but how do I, okay, so let me put you this way. Imagine there are no humans involved, only the system making decisions. When should the system roll back?
It's a metric.
Exactly. And when you start involving metrics, then you get something that I'm going to show you now.
Okay.
So without metrics, with just rolling one release, one replica at a time, without monitoring metrics, you don't know when to roll back.
Or tests, if you want tests after the deployment.
Yes, but tests are not really a good idea because, especially with containers and stuff, your applications are immutable. The test that I could run in staging, I already know that it works, that part. What I really don't know is what happens when real users start using my application. That's the part I don't know, right? I know that all my tests pass, right? And of course, there are always some differences between production and non-production, but with Kubernetes, those differences are becoming smaller than ever. So I'm relatively confident that my tests that passed before production will pass production as well. What I'm not confident is what happens when real users start using my application. That's my real worry. So the fourth one is Bluegreen. I'm not going to go through Bluegreen today because Bluegreen is silly. It's terribly, terribly silly. Everybody loves it because Martin Fowler is a great guy and he really well explained it. But I really think that Bluegreen makes sense only because it paved the way for things that make more sense, doesn't make sense anymore. And one of the problems that I have with Bluegreen is that it is extremely expensive for me to run Bluegreen because I need to multiply with 2 my whole infrastructure. So imagine now going to the extreme. If I'm really running big operations on Facebook or Netflix or whatever, am I going to multiply everything to 2 only so that I can have twice the same thing, and then at one moment, I can change the load balancer to point to the new release. And on top of all that, I'm still with Bluegreen, not certain whether it will work or not, because at one moment I'm gonna say everybody goes to the new release, let's see whether it works, and it might not. But if you want, we can fight about Bluegreen. That's my favorite fight. Everybody loves it except me, so that's okay. What we're going to do instead, I'm going to show you canary deployments which are variation of Bluegreen. That's like kind of Bluegreen of this century type of deployment. So let me show you how that looks like. Again, I'm going to do the same thing as before. I'm going to make a change. to my application. I'm going to go back, and while waiting for new release to be deployed, I'm going to show you what's going to happen. What we will do now is that we will be spinning additional pod. We will have primary and canary release. But what we're going to do is that we're going to let something called gateway, and gateway can be many different things depending on which technology you use, choose what percentage of the requests to send to one release or another. 20%, 40%, 60%, 80%, or everybody living in Europe and nobody from US, or only my logged in users, only my paid customers, only my testers. For example, you can say, only the people from my company who test my application can see it, right? Whatever the criteria is. I'm going to go simple now. My criteria will be percentage. I will be increasing based on percentage. But what I will be doing is that I will be watching metrics. I have some formulas defined for my application that say if majority of the requests need to be within certain period, respond within certain period of time, and the percentage of errors returned by my application needs to be below some thresholds and stuff like that. So I'm not going to just blindly deploy, move things. I will be watching metrics. Think of metrics as being what we discussed before, form of tests, and those metrics can be anything. And then depending on, oh fuck, wait, I need to hurry up. Wait, I'm gonna get that soon. I need to start running this command before it's too late. Hope it's not. The reason why I said I need, because if I don't start sending requests to my application, it will automatically roll back because there are no metrics, therefore something is probably wrong. Anyway. Where was I? Yeah, so watching metrics and deciding, depending on those metrics, whether to proceed rolling forward or potentially to roll back. And once it's finished, everything will be handled by the new release. And in this specific case, I'm using, what am I using? I'm using Flagger and Istio, I think, yes. And metrics are stored in Prometheus. But those are implementation details. You can do it in many, many different ways. That's really not the key here. Let me see whether this worked. Jax get activity, Jax Canary, I think that's how I call it. Okay. Is it deployed? Did I mess it up? Soon it will be deployed. This guy is deploying it right now. Started 36 seconds ago. Come on. I can actually see the progress get. No. Let's see the staging. No. Staging get Canary thing. Yeah, you can see that here. It just started progressing. The weight is 0, meaning that it did not yet start sending new requests to the new release. Let's see a moment later, still there. Come on. See how it changed here to 20%? Now 20% of requests are being sent to the new release. And you can see that approximately there, if you follow it, 1 out of 5 requests are responding with Canary. And right now it is watching metrics, it is collecting metrics from those requests that I'm sending, collecting error codes and what's or not, a bunch of stuff collecting and a bunch of stuff evaluating. And as long as all those thresholds are not reached, it will continue. When I say continue, I don't remember now, it's 40. Now it's 4 out of 10 requests are new release, and it will continue like that, on and on and on, until my new release is fully rolled out. Or I'm not going to simulate it now, but if one of those thresholds are met, then it will go back to whatever was there before. Basically, I automated QA department from the deployment process. And I'm going to show you. You don't deserve it. I have a dashboard where you can see it, pretty colors and all those things. So, which one? Recreate is when you have legacy applications, right? If your applications cannot work in parallel, multiple releases in parallel one way or another, needs to be recreate. And especially, there is one important rule. If your application cannot run multiple replicas, like for example, among other things, our product is Jenkins. Jenkins cannot scale, cannot have multiple replicas of itself. And without that, if you cannot scale it, it's impossible not to do recreate, because without running at least 2 replicas in parallel, and that's scaling already, you cannot accomplish no downtime. Rolling update is great, and it comes out of the box in Kubernetes, and it makes sense only if you don't know which metrics to watch. If you don't know how to collect metrics, if you don't know how to make a decision whether to move forward or not. Because basically canary and rolling deployments are the same, rolling updates are the same thing. The difference is only in decision making. Do you make a decision to move forward or not? And that decision is based on metrics or whatever else you can come up with. Rolling update whenever you need additional control, when you roll forward, when you roll back. And now, this is the trick part where everybody says, yes, I want this, because this is the coolest one. But in reality, it's very hard to make your applications use this. It's not kind of that you sit and for one afternoon you will redesign your application and you will generate all the metrics and God knows what, and have full confidence to use it. So it is cool, but no. And serverless is amazing when you have infrequent load and when you want scaling that is not really, you don't know how to define auto-scaling, and then Knative gets great because it does it out of the box, and you can continue living in oblivion. And my favorite for serverless, which I didn't show you today, I will tomorrow, is in preview environments or pull request environments. That's the best example that I found. Because normally whenever you create a pull request, you are creating pull requests, say you do. Whenever you create a pull request, somebody will review the code and application, right? And that application needs to be deployed. So if you have 100 pull requests in parallel, you have 100 instances of your application deployed. And most of the time, you're not really reviewing pull requests. And on average, huh?
They're just waiting.
Exactly. They're just waiting for somebody to review it. So you do need it running, but only when needed. And if there is at least in my case, that's the best example how serverless is amazing currently. When you do want to review it, send a request, wait for a few seconds, get the response, wait 10 minutes more, and then it will shut itself down. That's me. I work mostly with open source, and whenever I hear people complaining that something in open source doesn't work, instead of complaining, make a pull request. That's how you fix it. This is my blog. Read it. This is my podcast. Listen to it. Buy my book. Don't go to this address because before I came here, I destroyed the cluster where this site is running. So don't do this tomorrow. I will fix it tonight. That's about it. Yes?
I want to stress you on the topic about it's cost effective because you didn't mention what kind of, where you're hosting your cluster. So I imagine if it's some kind of virtualization or hypervisor, then by releasing the instance, you actually don't save money because you're releasing to company hardware. So it's somewhere in data center. So if you're running in cloud, then I would say that it's highly risky strategy to terminate your instances and pull back new ones, because once you add new one, you have risk that something will go wrong with networking. You need to ensure that all the things are there once you have your instance back and it's updated with things you need Also, you usually pay by hours. So, like one request per hour will cost you what, 1 hour, one instance hour. So, I doubt that it's cost effective.
So you have so many questions here. Let's go one by one. If you're running on on-prem, which I think was the first one, it is cost effective because you know what happens is that what happens on-prem today is that one team says I need 5 servers. And then another team says I need 7 servers. And then a third team says I need 15 servers. Nobody understands that actually everybody designs on-prem, not everybody, most of the people for the peak load. What is my peak load? This. That's how much servers I need, right? By scaling applications, not hardware, you cannot scale hardware on-prem because you're limited by whatever capacity you have. But by scaling applications themselves, going up and down, forget about serverless, doesn't have to be serverless. Normal applications should increase and decrease the number of replicas, and like that, you will be, when they decrease, you're leaving space for others to increase and the other way around.
So you need competing Kubernetes cluster, which is also utilizing these nodes you release.
Second?
You need
You need a Kubernetes cluster.
another one that takes the nodes that you release.
No, I'm not releasing nodes in on-prem ever. That doesn't make any sense. I am scaling my applications up and down so that they don't use resources they don't need, so that others that do need increase in resources are using it. Right? So if you have 2 applications, one strategy is that this is my peak load, this is what I need combined. But in reality, this is what happens, more or less. The application, the needs, and the traffic goes up and down all the time. Like a good example is, what are you using? What are you using for CI?
My hands,
Bash, okay. Pretend that you're not. Jenkins. Do you have a server from which you're running that?
Sure.
Right now, are you running anything?
Sure.
Really?
Yes.
Your hands are, okay, that's telepathy. I like it. Okay. But what I want to say is that you're most likely not using all the resources you need right now because you're here.
Yeah, I mean, the thing is, you're still paying for 5 servers or 10 nodes or whatever you have.
Yeah.
Right? It's just the elasticity within those servers, right? It's saving you money.
But what I'm saying is that with 10 nodes, you could potentially do what you do with 20 nodes in a traditional.
Sure, yeah, but you're still paying for those 10 nodes regardless, right?
Yeah,
So it's not
yeah.
necessarily your monthly bill will be the same, right?
Yeah.
Your electricity bill or whatever, but
Yeah.
you can fit more stuff in
What
there.
I'm saying, that the need to order more.
Yeah, you don't need to order 5 more because
Exactly,
you're
because
not
you have a
gonna-
new application.
You can achieve same thing by saying that each team has budget of $100 and shutting down everything which is above. Of course, not in production.
Why not in production? Why not in production? If nobody's using it in production, why not shut it down? That's the point. Imagine, huh? Yeah, but still, you can, okay, let's not shut it down. Let's put it from 15 to 1 replica.
Yeah.
Maybe let's put it to 3 replicas. Maybe not 1, because if it fails, it will be, you will need to wait 5 seconds until Kubernetes brings it back up or whatever you're using, but maybe from 15 to 3. Imagine if Google would go with the highest peak for all the applications.
All the time.
All the time. Kind of like that would be just too expensive. And now I already forgot the rest of your questions. If you repeat them, I will do my best to answer.
No, I guess it really depends what is your workflow, and how big is your application, and like what
Yes.
you're saying, if you have multiple teams competing for resources or you're a lone person doing your Kubernetes stuff, it really matters, like what are environment in which you operate.
Yeah, so that's kind of solved in Kubernetes because normally you would define, you would give different teams different namespaces, and within those namespaces you would define limits. Say, okay, I expect you to use 50 gigs, but I'm going to give you a limit of 100. When you use 20, what you're not using will be used by others. And then there are strategies you can define and stuff like that. So that's kind of solved problem. Unless you actually give each team a Kubernetes cluster, but then that would be overkill. Unless your team is Google, then again, everybody needs a different cluster, right? But normally you wanna help to share. Yes, please.
So, I remember you as a guy who told at some conference, like, if you're doing SSH into your server, then you're
Yes.
doing wrong.
Yes.
So, yeah, now I understand why. But my question is not about it at all. Yeah,
You're just trying to confuse me by switching from one side
yes,
to
yes,
another.
exactly,
Excellent.
exactly, yeah.
Okay.
So my question is about cameras, yeah? So back in the days, not so back, so we used kind of poor man's rolling update by like by changing the image of with new release to a same deployment. Yep, and we made a script that was actually pausing the rollout, watching metrics, and if like everything is fine, it resumed it, and gradually, slowly. So
That's canary.
Yeah, so it's fundamentally like same
Same,
thing,
yeah.
absolutely,
On a process level, it's the same.
absolutely same.
Yeah.
So because like you were talking about like rolling update was not like satisfying something.
No, but they said
And I was wondering, like,
rolling update in Kubernetes
Yeah.
itself
Yeah.
does not really watch your metrics outside of the health check, which is ridiculously
Yeah.
primitive.
Yeah.
So does rolling update in Kubernetes at least does not watch for metrics
Yeah.
to decide whether to move forward or not. You could modify rolling update, which is probably something. Were you talking about Kubernetes now or something else?
Yeah.
Kubernetes. Yeah, you can. Were you tweaking rolling update itself, right?
Yeah.
Yeah, so you accomplish the same thing. You just that
Yeah.
I was referring to rolling update as it was designed to be used, not extended by people like you,
Yeah, exactly.
which is great.
I saw like you have some kind of canary,
Yes.
like, and we didn't have. So, and the next question, like, what is that
Flagger.
feature?
So it's Flagger and Flagger.
And
Flagger.
the CRD.
Yeah, everything ends up being CRD in Kubernetes
Yeah.
one way or another.
Yeah.
So Flagger. So you need some kind of service mesh.
Yeah.
I'm not even sure which one I'm using. Istio, Linkerd, or whatever you're using. And then Flagger would actually Flagger would do the magic of changing the percentages in service mesh. So service mesh gives you the option to specify,
Yeah.
under these conditions go here, but it doesn't really out of the box go automatically and watch metrics. So Flagger.
Okay. Thanks.
Well, thanks for the talk. That was like interesting. I like the idea of rollback based on metrics. Just to get a little more practical on that topic. How do you define metrics? Which metrics to follow? Which metrics to collect? Which ones are important for the rollback?
I mean, general or in this example?
In general, I guess the answer will be too general.
Okay. So in this example, let me take a look. I want to show you.
So I'm asking because like it's a very practical problem that I'm having as well. Of course, we don't use Kubernetes, but nonetheless, like so many things can go wrong. So how do you decide?
See,
that
you cannot predict. First of all, nothing is 100% bulletproof. So you
Yeah.
cannot predict everything bad happening, right? You can, over time, you can be reducing the percentage of the bad things happening without you predicting them over time, right?
Okay.
Normally, when I work in consulting with other companies, I always tell them go easy, kind of like, okay, there are some obvious candidates, like for example, the percentage of non-200 responses, right? 500, 400 responses, right? That's a no-brainer. If you have bigger percentage in something, roll back. The response time, that's a no-brainer as well. Roll back and stuff like that. There are some things that are almost no-brainer. Again, they will depend from one case to another, and then over time, it's pointless. Anybody system architect here? Nobody? Excellent. So usually architects kind of like try to define everything in advance. I need to have everything documented. No, just start with 4. With those 2 that I mentioned, start with them. And then the point is, and this is now the most important part, you will not be able to predict what will go wrong. But what you can do is that when that something goes wrong, 2 things need to happen. First, how fast you can react yourself as a human. More importantly, can you incorporate that knowledge so that next time you're not involved in that? So kind of, I like monitoring my errors and trying to figure out how can I remove them from, not from happening again, I cannot predict that they will never happen again, but how can I teach the system what to do when those errors happen? And by the way, I didn't want to enter there, but rollback is a myth in most of the cases. It's impossible in most of the cases. If you change the schema and start of the database and start collecting requests with a new field and this and that, right? Very often you will not be able to roll back because what are you going to delete the data that was stuff like that, right?
What about if you use an spanner contract?
No, it just depends on how you
What?
manage migration.
What if you use a spanner contract? Like when you change the schema of the database, there's a technique that you can actually do rollback even when you change.
Yeah, but the point is that the moment a new transaction comes into the database, how do I roll back? One thing, I'm not worried about rolling back schema, that's easy, that's solved 20 years ago. What I'm worrying is that I cannot say, okay, so I'm going to delete all the data that was gathered from when I made the new release and until this point, I'm going to delete it. What am I going to do?
You roll forward, you roll back.
Yes, I was going in that direction, exactly. I mean, the best thing is to roll forward and fix the problem fast.
If you can,
The same thing
because
with rollback.
sometimes it's way faster to roll back than roll forward.
Yes, but sometimes it's not possible to roll back. And also, the speed with which you can roll forward is, in most cases, directly proportionate to the frequency of your releases. If you release once a year, rolling forward is going to take you probably a month or a week. If you release once a month, it's going to be shorter. If you release multiple times a day, how hard can it be to fix the problem that you made half an hour ago? Very easy.
For example, in my case, the whole going to the whole test environment and so on might take 2 hours from commit to deployment. While rollback takes 10 minutes.
Yeah, now we should start discussing what, yeah.
This is like questions and answers, right?
Yes, and I think that I'm
We are
eating time of.
running out of time, so let's make break. You can still discuss 10-15 minutes and then we continue.
Wait. I will try to give two shirts. Last questions.
They are different size. You just pick
Okay.
people and they come and choose size.
I accept bribes. I don't know. Who has most questions? Most questions. I don't know. Most questions. Very good.
One,
Pick
so
your size.
Two people.
Two people. Both sides.
Who are those two?
Left wing, right wing. Him,
You
him.
and okay, good. Thank you.
Okay, good.
And socks, there is saying in Latvia that the most important thing is that your feet are warm. So yeah, that's what we take care of.
Thank you, man.
Thank you.